Hey y'all, it's Raquel Mercado from Converse College. I am here to talk about multi-digit multiplication today, and I'm going to show you 5 different ways to do so. I know we've been learning in class how students use different methods to get to the same answer. So I might not use the same method as my peer, but we would eventually get to the same answer, which is really cool. And that's the same with multi-digit multiplication. You know, some kids just get it, and some kids just need a different way to get there. I've got 5 methods. I've got 4 that I actually taught when I was a 5th grade math teacher, and then I've got one that I learned about this week, which I think is completely mind-blowing, and I think it's really cool, and everybody needs to see it if you haven't so already. So we're going to start with what I learned 20 years ago in 5th grade. This was the only way to learn math, and that's with traditional algorithm. So, and you're going to have students that like this way, that find this way the easiest. I mean, honestly, I like traditional algorithm just because it is how I learn math. But have I found easier ways to do math? Absolutely, yes. So we're going to do this problem. 32 times 29 all day. So we're going to be getting the same answer all day, 5 different ways. So with traditional algorithm, this is how you set up your problem. And with traditional algorithm, I like to go over to the side and list my steps. So we've got 6 steps with traditional algorithm. And with the steps, you know, you want your students to make sure they're seeing all of them. So the first thing you're going to do, we're just going to jump right into it, is 9 times 2. You're going to start in your ones column. You're going to stay in your ones column. 9 times 2. Which we know is 18. So just like addition, tell your students, just like addition, you're going to write your 8, you're going to carry your 1. Second, 9, you're not done with your 9 yet, times 3. 9. But just like addition, you've got to add that 1 that we carried over. So we know, since we have nothing else, we can cross out our 1 because we use it. 9 times 3 plus 1 is 28. This is the step that you're going to want to really get in their brains if they're going to use this method. And that's going to be add your 0 placeholder. So just explain to them that this 2 and this 3, they don't represent 2 and 3. Because without this 2 and this 9, these are 20 and 30. 32, 29. So if these numbers weren't here, they would be zeros. So you got to add a placeholder. So I'm going to go ahead and do this in pink. This is your placeholder because you're in the tens column now. So I'm going to start with your 2. 2 times 2, because you've already put your placeholder, which we know 4. We have nothing to carry over. 2 times 3, which we know is 6. And then, oops, I'm sorry. I got a little carried away. 2 times 3, which we did. And then you add 8 plus 4, we know is 12. Again, this is simple math. Carry your 1, 9. 928. That is traditional algorithm. So the next one I'm going to teach you about, or show you if you don't already know it, it's called lattice multiplication. This one, I like lattice. Lattice is very interesting. So with lattice, you're going to simply start with what I like to call a window. And you're going to take, I like to take a different color. The students don't have to take a different color because usually they're going to be using pencil anyways. And you go to every corner and you draw diagonally. And the reason I say every corner is because you may have 4 digits up here, so you're going to need more boxes, but we're just sticking with double digit today. So I'm going to write my numbers across. 32 times 29. So the first thing I'm going to do is I'm going to fill in this box. So this box, we've got a 3 above and a 2 out to the side. We're going to multiply. Again, this is one of those things where they don't have to know double digit multiplication. This is just single digit multiplication. 3 times 2 is 6. So I'm going to do a 0 and a 6. 2 times 2, 4. 3 times 9 is 27. And 2 times 9 is 18. So then all you do is add. So you start at the bottom. So I tell my students to erase these numbers so they don't get confused. So I'll just do it exactly how I tell my students. And you just add your rows. 8, and you need to start at the bottom. 4 plus 1 plus 7 is 12. So this is where you gotta pause. Just like addition, you're gonna carry over your 1, 2, 6, 1 plus 0 plus 6 plus 2, 9, 0. So this is 0. And your answer goes this way. So our answer, again, 29 times 32, 928. Pretty fun, pretty quick, pretty easy. Okay, so the next method that I taught when I taught 5th grade is called box and cluster. Again, you're going to start out with a window, just like we started out the lattice method. You're going to start with a window. Then, this is where it gets a little tricky. You can go ahead and do 32 across. And I know some people do it a little differently, and 29 down. But this is where you have to pause and say 32. If that 2 wasn't there, what did we say the 3 represents? 30. So we're going to go ahead and make that a 30. Same with the 2. What does it represent without the 9? 20. And that is how box and cluster is set up. You're going to do the same thing you did on lattice. 30 times 20. It seems really hard, but all you got to do is, what's 3 times 2? 6. How many zeros do we need to add? 2. 2 times 20. What's 2 times 2? 4. How many zeros do we need to add? 1. 30 times 9, 270, and 2 times 9, 18. So we literally just went to the box, we went up, we went over, and we multiplied. So over to the side. Now, you're going to do 600 plus 40 plus 270 plus 18, 8, 7 plus 4 plus 1, 6 plus 2 plus 1, 928. That is the magic number today. So, the last method that I used to teach my 5th graders is called partial product. So, you're basically, it's basically exactly what it says, partial products. So, partial products. And you're going to set it up just like traditional algorithm. 32 times 29. And over here, this is what I like to do. And you're going to have more depending on your multi-digit, but today we only have 2 each, so you know you're going to have 4. So here, just like traditional algorithm, what do we start with? 9 times 2. 9 times 3, but what does the 3 stand for? 30. 9 times 30. 2 times, no, excuse me, what does this 2 stand for? 20 times 2. Then 2 times 3, but what do they stand for? Kind of like box and cluster, except you don't have the box. It's very similar. So 9 times 2 we know is 18. 9 times 30 we know is 270. 20 times 2 we know is 40. And 20 times 30, 600. We're going to add those up once again, just like we did on box and cluster. 8, 12, carry our 1. There's our magic number again, 928. Awesome, right? These are so cool, y'all. Like, it's so fun learning new ways to do something, especially, you know, I hear all these people saying, you know, we didn't have that when we were younger, and we didn't. I knew traditional algorithm and I knew long division. That was it. If you didn't get it by that, you didn't get it. So, thank God math was my strong subject. So, this last one is called half and double. Sounds crazy, right? I was sitting here, when my professor first showed me that, I was like, what even is this? I'm going to show you what it even is. It's amazing. So I'm just going to write 32 times 29 again. So what you're going to do is you're going to pick a number to half. Then whichever one you don't half, you're going to double. So clearly, looking at this one, I know that I'm going to want to half the even one. So we know half of 32, 16. So now we have to double 29. I can do it in my head just because I know 30 plus 30 is 60. 2 less is 58. But let's half it again. No, I could probably still do 58, but I'm going to show you how you would tell your students to do it over to the side. Just tell them to do this. 58 plus 58. 8 plus 8 is 6. Carry 1. 5 plus 5 is 10. Plus 1 is 11. So we halved our 16. We're doubling our 58. We're going to half our 8. We're going to double our 116. And you can use the same 116. So 6 plus 6 is 12. Carry your 1. 3, 2, 232. Guess what we're going to do? We're going to keep halving it. 2 times, we've halved our 2. We've got to double our 232, which comes out to 464. And guess what? Because of the identity property, we're halving our 2. Anything times 1 is itself. So 464 plus 464. 4 plus 4 is 8, 12, 9. Look at that magic number. Sorry. Look at that magic number, y'all. 928. Can't barely see money. How amazing is that, y'all? That's literally probably my favorite way to do multi-digit multiplication now. I'm going to show everybody. So anyways, I have shown you 5 different ways to do multi-digit multiplication. Again, don't forget that students can get the same answer, but they don't have to take the same path. So that's really amazing. And one thing I would do with these is I would make an anchor chart and show them on an anchor chart. Laminate your anchor chart and use it for years. Post it on your wall. Let them use it. Let them know. And, you know, when you're explaining these, essentially what I did was I would show them how to do it, and then I would have them come up to the board and do 1 or 2, and then we would move on. And again, I made an anchor chart, so that was on the wall for the rest of the school year. So I appreciate your time. I hope you learned something. I hope you're able to use some of these in your classroom to help your students better understand multi-digit multiplication and get to the answer in a different way. Y'all have a good day. Bye.